So here we're going to look at rationalizing the denominator. Now, the key thing we want to know about this is that we never want a surd to be the denominator of a fraction. For example, if you had 1 over 2 root 7, that's not what we want our fraction to look like. So we need to find a way to fix that up. So let's look at this one. Let's use that as our example to start with. We've got 1 over 2 root 7. So we want to rationalize that. Now, what I want to ask is if I multiply that by 1, it's not going to change anything, is it? Whenever you multiply a number by 1, it won't change the number itself. So if I multiply that by 1, it simply equals 1 over 2 root 7 again, doesn't it? I also want to ask, if I have, let's say, just use the number x over x, whatever I choose x to be, that fraction equals 1, doesn't it? So I can use this. If I have 1 over 2 root 7, I can multiply it by some fraction, x over x. Because x over x is always going to be 1, we're not actually changing the number, okay? So I can choose x to be any number, and I'm not actually going to change the fraction. So similar to simplifying fractions, the same way, say, 2 over 4, or better yet, 1 over 2, if I multiply it by 2 over 2, it becomes 2 over 4, which we know it is the same as 1 over 2. So we're just sort of looking at how to change or simplify this fraction. What I'm going to do is I'm going to choose x to be root 7, and we'll see what happens when I do that. So we've got 1 over 2 root 7 multiplied by root 7 divided by root 7, okay? So this fraction is equal to 1, so we're not changing anything here. But what happens is, we know how to multiply fractions. When we're multiplying fractions, we multiply the two numerators together, and we also multiply the two denominators together. So if I multiply 1 by root 7, we get root 7 as our numerator. And on the bottom, I've got 2 root 7 multiplied by the square root of 7 as well. Now, if we remember, if we have, say, root a times root b, it is equal to root a times b, all in there. So I can use that sort of square root rule to help us solve this one. So we've got 2 times, because we've got root 7 times root 7, it's times root 7 times 7. Let's continue to simplify this. 2 times 7 times 7 is root 49. The square root of 49 is 7. So we've got root 7 over 2 times 7. And 2 times 7 is 14. So we end up with root 7 over 14. So that did involve a few steps. Some of you might recognize let's sort of rewrite it again. So 1 over 2 root 7, because we've got our surd as root 7, that's why I'm choosing root 7 over 7. You might recognize straight away that 1 times root 7 is root 7. And we've got 2 root 7 times root 7. When you have root 7 times root 7, the product is just going to be 7, okay? So instead of going through all these steps, after you've done it a few times, you might instantly recognize you can go from this step straight to 2 times 7 there. So you would know that it's 2 times 7, which is 14. So 1 over 2 root 7 is the same as root 7 over 14. If you want to convince yourself that that's true, you could type both of these fractions into your calculator, and when you convert them to a decimal, they will turn out to be the exact same number. Let's look at another example quickly. I've got 1 over 2 minus root 3. Now, using the other one as an example, your instinct might be that multiplying by root 3 over 3 is going to help us rationalize this denominator. But let's see what happens, and we'll find out that it doesn't actually work out quite as well. So we multiply our two numerators, 1 times root 3, which is root 3. Then we're going to multiply the entire, I might put brackets around, it'll be a bit easier to see. So we're going to multiply the entire 2 minus root 3, all multiplied by root 3. So we're going to have to go root 3 times 2 and root 3 times negative root 3. So root 3 times 2, we get 2 root 3. Then negative root 3 times root 3, we're going to end up with minus 3 there. And now this hasn't really changed much for us. We've still got a surd on the bottom. We've still got this root 3 on the bottom, and the two numbers are still separated by this minus sign. So in this case, multiplying by root 3 didn't help us. So there's an extra piece of mathematics we're going to need to know to help us out here. And that would be dots, which is the difference of two squares. So you may have came across this rule before, but if not, we have, this is the rule, we've got a squared minus b squared is equal to a plus b multiplied by a minus b. Now, you can convince yourself this is true if you want to write out a plus b multiplied by a minus b. When you start doing all your when you actually do all your multiplications and you simplify it, you will find that it is equal to a squared minus b squared. We can use this rule to help us out here. So let's redo this example. So what we actually want to multiply by, we've got 2 minus root 3. We want to multiply it by the opposite one. So I want to multiply it by 2 plus root 3 all over 2 plus root 3. So you should know that this fraction is still equal to 1. So just like our root 3 over root 3, we're not changing this fraction because this is still technically equal to 1. Now, let's see what happens. So we've got 1 multiplied by 2 plus root 3. So we know our numerator won't change. Our denominator, however, we've got 2 minus root 3. And it's multiplied by 2 plus root 3. And this is where our dots equation helps us. We've got 2 minus root 3 multiplied by 2 plus root 3. That looks like that, doesn't it? Where our 2 is our A and root 3 is our B. So we know that that is equal to A squared minus B squared. So if 2 is our A, 2 squared is 4 minus B. B is root 3. So root 3 squared will just be 3. So we're going to minus 3 there. Now we don't have any surds on the bottom, and this is just a simple subtraction sum. So 4 minus 3 is obviously 1. So 2 plus root 3 all over 1. When you have a 1 as a denominator, we don't really need to write it there. So that simply equals 2 plus root 3. And just as before, if you want to convince yourself that this is correct, you can type that into your calculator and type that into your calculator, and you should find that they're equal to the exact same number. All right, we'll quickly do one last example of rationalizing the denominator. So we've gone with 3 root 7 divided by 3 minus root 2. Now to rationalize the denominator, we're going to use dots again. So because 3 minus root 2 is our denominator here, we want to multiply by 3 plus root 2 over 3 plus root 2. Because when we multiply these two denominators together, it's going to work like our dots equation, and we're going to end up with a denominator that is not a surd. So we multiply our numerator by our denominator. We've got 3 root 7 multiplied by 3 plus root 2 all over 3 minus root 2 times 3 plus root 2. Let's start with our numerator. We've got 3 root 7. We need to multiply that by 3. So that would be 9 root 7. Then we've got 3 root 7 multiplied by positive root 2. So we end up with 3 root 2 times 7 is 14. So 3 root 14. That's going to be all over. So this would be, if we check out our dots equation again, 3 is our a, so we've got a squared, so 3 squared is 9, and we minus b squared. B is root 2, so root 2 squared is just 2, so it's minus 2. Now we can simplify that. We've got 9 root 7 plus 3 root 14 as our numerator, all over 9 minus 2 is 7. Now, 9, 3, and 7 don't have any common factors, so we can't simplify that. What you could choose to do, though, you may notice that 9 and 3 have a common factor of 3. So you could choose to write it as 3 multiplied by 3 root 7 plus root 14 all over 7. But really, either one of these is probably okay.